Hello everyone. In this session, we are going to discuss the concept of duobinary encoding without precoder, duobinary encoding with precoder, and then later on in the next lecture of mine, we are going to discuss its modified version, that is modified duobinary encoder without precoder and modified duobinary encoder with precoder. Now if we see all these four heading, in all this the one name is common, and that is duobinary encoder and decoder. Duobinary encoder decoder. So what is this duobinary encoding technique is, or what is this duobinary encoder? So basically duobinary coder is the one which is converting uncorrelated sequence of having two levels into a correlated sequence with three levels. So first of all, one should know what do you mean by correlative coding, because this is all about the correlative coding. Correlative coding means what? The sequence that we are going to get is having the dependency on the previous bits, or they are having dependency on the previous bits generated. However, uncorrelated codes means the codes which don't have any dependency over the previous generated bit. Now what is duobinary encoder encoding we have defined here? So duobinary encoding technique is the one in which uncorrelated sequence with two level, let's say level 0 and level 1, is converted into the correlated sequence with three level 0 plus or minus 1 or 0 plus or minus 2. So if you see, these are the uncorrelated sequence with two levels, level 0 and level 1, and this will be converted into uncorrelated sequence with level 0 plus 1 minus 1, means 3 uncorrelated sequence, or the levels might be 0 plus 2 minus 2. So you might be clear with the correlative coding now. Correlative coding means what? Whatever the codes that are generated, that will be depending upon the previous generated bit, or they have certain dependency over the bits. However, in uncorrelated sequence there is no dependency, since it's named correlative coding, so there is certain relationship between the bits generated. However, uncorrelated there is no relationship. Now let us discuss first of all for what purpose we are going to discuss the duobinary encoding technique, or what is the use of this duobinary encoding technique. The one and foremost use of this duobinary encoding technique is to reduce the bandwidth of the baseband signal, as this is used in the baseband binary transmission. First of all, you should know what do you mean by baseband binary transmission. So baseband binary transmission means we are going to send the baseband signal over the channel as it is. We can't use here any modulation technique, means we are not mixing any carrier signal in the message signal. So in baseband binary data transmission, we are transmitting baseband signal as it is. Now if this baseband signal is having much more bandwidth, then it will occupy much more space in the channel. Now to reduce the bandwidth of the input signal so that it will consume less space in the channel, we require certain techniques, and one of the technique is this duobinary encoding technique. So basically in this duobinary encoding technique, our aim is to reduce the bandwidth of the input signal, that is our baseband signal. Now how the bandwidth, we know the definition of bandwidth. How can we say that with the help of this duobinary encoding the bandwidth is supposed to be reduced? So we know that bandwidth of any baseband signal is nothing but, according to the Nyquist criteria, the bandwidth is nothing but twice of the maximum frequency signal, right? Now this formula I can also write as we know frequency is 1 upon time period, so 2 upon max the minimum time period, right? Twice of fm. Now this will be 2 upon the minimum time period. Now if we are trying to find out the bandwidth of this, let's say a baseband signal, let's say 10, it is having a time period tb. Now the minimum time period here is tb, so 2 upon TB. Why? Because the total time period, minimum time period is TB. This is not maximum, this is minimum time period. So what will be the bandwidth here? 2 upon TB is nothing but twice of FB. 1 upon TB is bit frequency. So the bandwidth of this particular baseband signal, we can call it as a uncorrelated signal. Let's say for example is nothing but twice of FB. Now why I call this as a uncorrelated sequence? So if we consider suppose BPSK modulation. So if we mix up this input signal with any carrier signal, let's say this is the carrier signal, we are getting a BPSK signal. So how? When 1 is multiplied with this signal, we are getting this signal as it is, and when 0 means it is having -1 level. So when -1 is multiplied, we are getting inversion. So we are getting, whenever it is 0, we are getting 180-degree phase shifts in the signal, whereas whenever it is 1, we are getting 0-degree phase shifts in the carrier signal. So why this is uncorrelated sequence? Because from this data we can demodulate the data directly once. So whenever 0-degree phase shift, we will receive it as 1, and whenever 180-degree phase shift, we will receive it as 0. So this is uncorrelated sequence, means there is no dependency of received sequence over the previously generated sequences. Directly from the data we can receive it. Now let us look at the dependent sequence or the correlated sequence. So how to find out the bandwidth of that correlated sequence? Now let us consider suppose bandwidth of the baseband signal in case of duobinary encoding. So in duobinary encoding, we know that the total time period is nothing but, it will, as the sequence is a correlated sequence, means it's a dependent sequence. So it will be not just depending upon that bit, present bit, but it also depending upon the previous bit generated. It means the total time period will be TB plus the previous bit TB plus TB, it will be twice of TB. So as we know that the bandwidth is nothing but twice of maximum frequency 2 by total time period Tm, and now the Tm is not just TB, it will be twice of TB, because it will be generating upon the previous bit also along with the present bit. So TB plus TB, it will be twice TB. So when I use here this value 2 TB, 2 cancel, it will be 1 upon TB and FB. Now if you see the bandwidth of this duobinary encoding scheme, now it is FB, whereas in the previous case the bandwidth is twice of FB. So if you see, the bandwidth is almost reduced. So bandwidth of the input signal is going to be reduced, and it is almost reduced by an half. So we can say that now as the bandwidth of the input signal is reduced by an half, so it will take only half bandwidth or space of the channel. Obviously, if the bandwidth of the input signal is reduced by an half, it will take only half of the space in the channel, and hence the speed will be double. Means we can transmit the input data with much more data rate or with much more speed. Why? Because we are having much more space available in the channel. Hence, in duobinary coding, the word duo means to double the transmission capacity of the binary system. So duo means what? The speed, the transmission capacity of the binary system is doubled. That's why the name is doubled. So one thing is clear, I think, from this particular discussion. With the help of duobinary encoding, we are going to reduce the bandwidth of the baseband signal by an half, so that the transmission speed will get doubled. And how it is possible? It is possible with the help of correlative coding. You know, correlative coding, it means it is having the dependency on the previously generated sequence. So it will increase the time period, since it is depending upon the present bit as well as the previous bit. Therefore the total time period is twice of TB. Hence when the bandwidth is twice divided by Tm now 2 TB, 2 cancel, 1 by TB, 1 by TB is the frequency FB, and this is how the frequency is supposed to be reduced. So the bandwidth is also going to be reduced. So this is what the reason behind using duobinary encoding. Now one by one we are going to discuss this all 4 techniques: duobinary encoding without precoder, then duobinary encoding with precoder, then modified duobinary encoder without precoder, and with precoder. Now in this session we are going to discuss first 2, that is duobinary encoding without precoder and duobinary encoder with precoder. So let us take now the first, that is duobinary encoding without precoder. So this is what duobinary encoder and decoder section here. So this duobinary encoder, let me discuss it. It is composed of, first of all, the input binary sequence, this bk, it might be 0 or 1. We can give it to the level shifter. What this level shifter does, so it is converting this bk into ak, means if it is 0, it will be converted into -1. If it is 1, it will be converted into +1. So it's just a level shifter. It is converting two levels 0 and 1 into +1 and -1. If 0, -1, if 1, it will be +1. Now this AK, we can give it to the adder. So this adder is having two inputs, one input AK as it is and another is the delayed version of this input. So this AK is delayed by how much time period? A single time period, that is TB duration. That's why AK -1, and therefore we are getting output sequence CK. So CK is the output of the encoder. Now this output will have to transmit it to the decoder, means to the receiver side. So here it comes to the received sequence. Now this received sequence we can give it to the adder, or I would say subtractor, where the another input is nothing but the delayed version of the output of this subtractor, and then the final output we can give it to the decision device, where we are setting some threshold level and we are getting the final output, that is bk cap. However, this output must be equal to the input of the duobinary encoder that we have transmitted as an input sequence. Now let us discuss one by one what happens at the input of the duobinary encoder. So as I said, this bk is having the level either 0 or 1, either 0 or 1, and when we are passing this to the level shifter, when we pass this through level shifter, if bk is 0, it will be converted into -1. If bk is 1, it will be converted into +1. Now let us look at what happens at the output of this duobinary encoder. So what is the value of ck? Ck is nothing but ak plus ak -1. So that is what I have written here. ck is nothing but ak plus ak -1. Now we'll have to look at the receiver also. So let AK cap represents the estimation of AK. As I said, it's a correlative coding. So we are going to estimate the bits. We are going to predict the bits from its previous bits. So if we can say that AK cap represents the estimate of AK, then we can obtain AK cap here. So if you see this receiver AK cap, it is nothing but this transmitted sequence CK and delayed version of this AK cap -1. So that's why I have written here AK cap is equal to CK minus AK cap -1. This is CK and minus AK cap -1. Now this AK cap value we can give it to the decision device, where we are setting the threshold level at 0. So we are getting the final value BK. So how the decision device make the decision? So if this AK cap value is greater than 0, the output is equal to 1, and if AK cap value less than this threshold value 0, then output is equal to 0. So this is what the operation of the duobinary encoder and decoder. Now let us try to study these things with the help of example. Before that, let me tell you here one drawback of this duobinary encoder without precoder. So at the receiver, we know that AK cap is equal to CK minus AK minus 1. This is what the equation we have written here. AK cap is equal to CK minus AK minus 1. Now if the transmitted sequence CK is received with the error, means the whatever the output of the transmitter that is coming from the encoder, if that itself is having the error, what will happens? That will propagate in an error. If CK is having the error, it means what? It also produces the error in the AK, and this error will propagate in the output sequence because it's a dependent sequence, and this is what the limitation. If the error is there in the transmitted sequence, it causes the error in the complete received sequence, which is what the drawback of this system, which will be overcome in the next session, that will be duobinary encoder with precoder. So precoder there we can use to avoid this particular error. Now let's see the example of duobinary encoder without precoder. So this is what the example. Let me come up with, let me first of all look, let me read the statements here first of all. So the example is the binary data 00110101 are applied to the input of Duobinary system. Question number 1 is construct the Duobinary coder output and corresponding receiver output without precoder. And second is suppose that due to the error during transmission, the level at the receiver input produced by the third digit is reduced to 0. Construct the new receiver output. Okay, one by one we will see this. So first of all, they have given us this input data 00110101 and it is applied to the Duobinary system. They ask you to find out the output of the Duobinary encoder. So first of all, we are going to find out the output of the encoder and we are also going to receive it, and then later on we can add any error in the transmitted sequence, and then we'll see how it is producing the output in the received output also. So let's see one by one. First of all, the first table is of number 1 problem. So we can prepare here a table. First row is of sequence. In this, different sequences we can write, and these are the different values of k, means for the different bits. So first of all, we can write the input data, the binary sequence whatever given bk. So this is 00110101. So it must be started from k is equal to 0 bit. So this is 0th bit, first, second, third bit, likewise this is 7th bit. Okay, now I can write next value as the bipolar sequence AK. Bipolar sequence means what? We'll have to pass this signal to the level shifter. So this signal 0, it will be nothing but it is -1. 0 means -1. 0 means -1. 1 means +1. This 1 means +1. 0 means -1. This is +1. 0 means -1, -1 and +1. So this is what after this input signal passing to the level shifter. Now the next is we'll have to write the value of AK-1. Now AK-1 means delayed version of this. Okay, so initially we'll have to consider the value of AK. So we can consider here the value of AK as +1. You may consider it as -1, but somehow you need to consider the initial value of this AK. So here I have considered this as +1. So here I make a star here. You must have to consider any value here. Either you can consider +1 or -1. Now if this +1, now this is what the delayed version. So this +1 will be coming here. This -1 will be coming here. This -1 will be here. This +1 will be coming here. This +1 will be here. This -1 here. This +1 here, -1 here, and this -1 coming here. So this is what the delayed version of this AK-1 is nothing but delayed version. So this is what the delayed version by one duration only, 1 TB. Now let me write the value of CK. So CK means what? It is AK plus AK-1. You might be knowing this diagram. If you see CK is AK plus AK-1. So let me write the value of CK. CK is AK plus AK-1. So -1 plus 1, it is 0. -1 minus 1, -2, 1, 0, 2. This is +2. This is 0. This is 0. This is 0. This is -2, and this is 0. So as you can see here, the uncorrelated sequence, this is uncorrelated sequence, is converted into correlated sequence with 3 levels. It is having only 2 levels, 0 and 1, means plus and minus level. You can see plus and minus. It is having 3 levels, 0, 0, +2 and -2. So it is having 3 uncorrelated levels. Now the next is AK cap minus A cap K-1. But before writing this, first of all we can write the value of AK cap. What is AK cap? AK cap is CK minus AK-1. You can see this is what the decoder. This is what the decoder, and what is the value of AK cap? It is CK minus AK cap -1. So initially we'll have to consider this value as whatever we have considered, same value here AK. So which value of AK we have considered? +1. So the same value of AK we can consider here. You may consider -1, that is also, but you will, even though we are considering -1, you will get the same answer. So here the value of this AK, I can consider it as +1. So here I can make a star +1. Now this is the delayed version. AK -1 is the delayed version of this AK. So this +1 will be going here. Why? Because it's a delayed version. So it is, this +1 is generated at -1. So obviously for AK -1, this +1 will be generated at 0 times. So this +1 is here 0. Now you know AK cap is CK minus AK -1. So this is CK and this is AK -1. In dono ka subtraction, we'll have to do the subtraction of this two. So 0 minus 1 is -1. Now this -1 will be coming here. So -2 minus minus +1. So -2 plus 1 is -1. Now this -1 will be going here. So 0 minus minus +1. This 1 is going here. 2 minus 1 is 1. So this 1 is going here and 0 minus 1 is -1. This -1 is going here. 0 minus minus is +1. Now this 1 is going here. So 0 minus 1 is -1. This -1 is here. So -2 minus minus +1. So this is -1. And this -1 is going here. So 0 minus 1 is +1. Now let us write the final output, that is binary sequence. So this is what nothing but the output of the decision device. And what decision we have seen? If the value of AK cap is greater than 0, it will be 1, and if it is less than 0, it will be 1. So since it is less than 0, it is 0. It is less than 0, so it is 0. It is greater than 0, so 1. This is 1. This is less than 0, so 0. This is greater than 0, so 1. This is less than 0, -1, so 0. This is also 0, and this is greater than 0, so it is 1. So if you see this BK and this transmitted sequence, it is one and the same. 0 0 1 1 0 1 0 0 1. So this is how we are receiving the sequence. Now what we can do, we are going to apply, as per the second case, we are going to consider the error is generated during the transmission in which bit? Third digit. So let's see if the error is there generated. So what will happen? Now first of all, let me write the transmitted sequence CK without error. So CK, I think this is what the CK I am going to write here. So 0 minus 2 0 plus 2 0 CK I am writing 0, then 0 0 minus 2 0. So let me check it once again. CK, that is the output of the encoder. 0 minus 2 0 plus 2 0 0 0 minus 2 0. Now the error is generated in which bit? Third bit, matlab first, second, third. So now the error is generated here. Okay, that is what they suggest us. Suppose that due to the error during transmission, the level at the receiver input produced by the third digit is reduced to 0. So the error is now reduced to the 0. Third digit, I think it's not given in the third digit, then it is in the second digit, not in the third digit. Sorry for this. Here we can write, this is not in the third digit, we can write here in the second digit. Okay, so now if the error is available in the second digit, so this is actually 0 as it is, we can consider this as 0 only. Now this -2 where the error is occurred, it means it will be reduced to the 0. So -2 is now having the error, it means it is reduced to the 0, and this 0 as it is, this 0 as it is, plus 2 as it is, 0 0 0 -2 0, rest of the things are as it is. Now let me write here the value of AK minus 1, AK cap minus 1. This is what the estimation of AK minus 1 from the AK cap minus 1 from the AK minus 1. So before writing this, first of all I can write the value of AK cap. We know that AK cap is CK minus AK cap minus 1. So first of all the same thing we can write here. It is plus 1. Since we have considered, we can write it as it is. Now this is what the delayed version of this AK, so that can be written here plus 1. And now let me take the subtraction of this 2. 0 minus 1 is minus 1. This minus 1 is coming here, so 0 minus minus is plus 1. This 1 is here, so 0 minus 1 is minus 1. This minus 1 is here, so 2 plus 1 is plus 3. Plus 3 plus 3 is going here. 0 minus 3 is minus 3. Minus 3, so 0 minus minus is plus 3. This 3 is going here. 0 minus 3 is minus 3. Minus 2 minus minus plus is 3. 3 minus 2 is 1. This 1, 0 minus 1 is minus 1. Now let me write the final sequence, means the decision. So less than 0 it will be a 0, greater than 0 it will be a 1, less than 0 this is 0, this plus 1 greater than 0, so it is 1, this is less than 0, so 0, plus 3 greater than 0, so it is 1, less than 0 it is 0, greater than 0, 1, 0, 1, 0. Now if you see 0 1, if you say this, what will happen? If the error is generated in the third, we are not even receiving the next of the bits. Actually this is 0, okay, we have received it properly. The next is, actually we wanted it as 0, but we have received it as 1 because of the error. Now the next bit we wanted it as 1, but we have received it as 0. Then this bit is properly received, even this bit is properly received, this is also properly received, this is also properly received. But if you see here, this is not properly received. We wanted 0, but we have received 1, and this is also not properly received. It means what? Since dependency, if the error is generated in any previous bit, that will causes the error in the next sum of the bit. And this is what the disadvantage of this duobinary encoder without precoder.